Hello, welcome to the first topic in CS218 Design and Analysis of Algorithms. So, this topic is about uh, counting poetic meters, which is an introductory topic I have chosen to give you a flavor of the course. So, in a large part of the course, we will design algorithms, and these algorithms will have the algorithm design problems will have the following form. So we will be given some constraints uh, on the structure of an object. Okay, and our goal would be to decide whether any such object exists so that it satisfies the constraints, and maybe even how many such objects can be constructed satisfying the constraints. Okay, so it could be a counting or an existence question. And furthermore, it may also be that if many constructions are possible, many objects can be constructed, then we might want to know what is the best as per a certain optimization function. Now, in this lecture, we are going to take an example of this general framework, general scheme of things that you will see in the course. So we are going to count the number of so-called poetic meters that can be constructed. And this is a problem from ancient India. It actually is a problem related to poetry. You will see details in a minute. And just very quickly, a poetic meter, we are not going to worry about poetry, but we will see that it can be thought of as a sequence, a numeric sequence, and with certain constraints and properties. So our problem will be counting how many poetic meters we can construct satisfying a certain constraint. But poetic meters are not computationally extremely important or anything. They are just a nice fun problem. But the ideas, the techniques that we will see will be applicable to many other very interesting and very relevant problems. This also will be a rather interesting problem. Okay, so what is a poetic meter? A poetic meter indicates the singing style of a poem. So let me take an example. Perhaps a famous poetic meter is the so-called Shardul Vikridit. So you may have heard this shloka which is in the meter Shardul Vikridit. So let me sing it. Let me sing it with some rhythm. So here it goes. So Ya Kunden Dutushar Har Dhavala. So did you hear what I was doing? When I sang Ya, I had two beats on it. When I sang Kun, I had two beats. Then also had two beats. Du, Tu had one beat each. So this is the pattern. So the numbers on top indicate how many beats you have to sing that syllable for, or how long is that syllable. Okay, so the pattern of these lengths produces interesting effects, pleasing effects, musically pleasing effects, and therefore uh, prosodists who study such things are interested in designing interesting poetic meters. So what is a poetic meter? For our purposes, it's just going to be a sequence of ones and twos. So Shardul Vikridita is this sequence, the sequence of numbers written on the top, which I have reproduced over here. The length of the sequence is going to be the number of syllables in each line of the poem as it is over here. And the ith number in the sequence effectively gives the singing duration of the ith syllable. So the first number gives the singing duration of the first syllable, second gives the singing duration of the second syllable, and so on. And clearly the sum of the sequence, the numbers in the sequence gives the total singing duration, or the total time required for that meter. So for Shardul Vikridita, if you count, there are 19 syllables in all. 11 of them are long or have duration 2. 8 of them are short or have duration 1. So the total duration is 11 times 2, 22 plus 8, or 30. And the question that we are going to address is how many poetic meters have a given duration d. And this, in fact, was the question asked by Virahanka, who was an Indian prosodist from the 6th or 8th century AD. You know that in ancient India, the time element was a little bit hard to decipher, but he's a very old from old times. So this is the problem that Virahanka posed, and our goal is to write a program to find the answer. So counting poetic meters is an example of a packing problem. Okay. So what are we packing? Well, we are packing syllables into a duration d. And we are asking how many ways are there of packing syllables into a duration d. Now, the techniques that we learn are going to be useful for more complex packing problems, more interesting and more useful packing problems. So, for example, you may ask, in how many ways can you give change for d paise using standard coins? Or you may ask, what is the minimum number of coins needed to give change for d paise? Or you may ask, how to fill a container with items of maximum value. Okay? And then the solution to our poetic meter counting problem will turn out to be a problem, to be something that you know by an Italian name. Okay, but you will see that this is actually an older problem, and I hope you are excited by this, because this says that, look, there was interesting math going on in ancient India, and of course, well, there is math in poetry as well. Okay, so let's explore this problem a little bit. So let us say that V of D denotes the set of poetic meters of duration D. So what we are asked is not V of D really, but we are asked the cardinality or the number of elements in this set V of D for a given D. Okay, so let's take a few examples. So V of 1 is the set of poetic meters of duration 1, and obviously there is just one possible set, and that set contains the number 1. Okay. V of 2, well, we want sets in which poetic meters have duration 2. So what can there be? Well, both durations could be 1, or there could be a single syllable of duration 2, so that the total duration is 2. V3 will get a little bit more complicated, but not really much. You can make the duration 3 using all ones, or using a mix of ones and twos. So these are the possibilities. V4, okay, you can work it out by trial and error. Okay, so what have we done here? What have you found? So since we were interested in the cardinalities, we have found that cardinality of V of 1 is 1, cardinality of V of 2 is 2, cardinality of V of 3 is 3, and cardinality of V of 4 is not 4, but it is 5. Okay, so the sequence is a bit more interesting than just 1, 2, 3. And this is what we are asked to do, and I guess we could do this by trial and error, somehow muddle along. But we really want a method which is less laborious and also more reliable. So Virahanka not only posed the problem, but he also gave a nice solution. And in fact, we are going to see Virahanka's solution. So here is what Virahanka said. So Virahanka said, look, consider any poetic meter belonging to the set V of D. Okay, so what is that? V of D is the set of all poetic meters of duration D. So consider any poetic meter of duration D. And D equal to 1 and 2 we have already explored, and they are rather trivial. So let's take something a little bit more interesting. Now, the first number in the meter can be a 1 or 2. Of course, I mean, there are only 2 syllables, 2 durations possible, 1 and 2. So the first number in the meter has to be 1 or 2. If the first number is a 1, then the rest of the meter should add up to duration d minus 1, or the rest of the meter should have duration d minus 1, because the entire thing is supposed to have duration d. So then the question is, how many meters starting with 1 can there be in V of t? How many meters of this type? How many meters that start with 1 can there be in V of t? Now, following this 1, we could have any duration d minus 1 meter, right? We can tag along a meter of duration d minus 1 after this 1. And absolutely any one of those will do. So, it seems that we will have V of d minus 1, such cardinality of that, such meters in V of t. That is, the number of meters starting with 1 in V of t is going to be this, cardinality of V of t minus 1. Because that 1 can be tagged, can be appended with any meter of duration d minus 1, and there are only so many, there are exactly so many such meters. Okay, so they will form one part of V of t. If the first number is 2, then the rest of the meter should have duration d minus 2. Okay, so how many meters starting with 2 can there be in V of t? Well, same logic. Any meter with duration d minus 2, if you append to 2, will give you a meter with duration d. So you can take any such meter, any meter with duration d minus 2, and append it to 2, and you will get a meter of this type. So cardinality of V of d minus 2, such meters will be present in this set V of t. Okay? So what is the summary of this? The set of poetic meters of duration t is equal to 1 prepended to each poetic meter of duration d minus 1. Okay, that's what we said over here. Unioned with 2 prepended to each poetic meter of duration d minus 2. These two sets clearly are mutually non-intersecting, because these start with 1 and these start with 2. Okay, and these, each meter of duration 1, d minus 2 and d minus 1 are distinct. So these completely form, this is a well-defined set, this is another well-defined set. Well, this is Viranka's observation, but you can see that it actually solves the problem that Viranka posed. Why? Because the cardinality of this is equal to the cardinality of this plus the cardinality of this, since these two are disjoint. So if you want to find the cardinality of this, if you know the cardinality of these, you will get it. Okay, so we are going to pause at this point. Okay, but when we pause, I'm going to give you some things to think about. Okay, so for example, I want you to think about why we said d greater than 2 in the first line of the analysis. Is that condition used anywhere in the argument that we wrote down? Okay, so you should think about that. And you should work out the argument for the proof of d equal to 5. So if you put 5 instead of d in that argument, how will the proof look like? So in particular, we said that we can construct V of 5. So will you indeed, so do construct V of 5 as per the method given in the proof, and then by trial and error, please check whether that in fact is the actual set V of 5. So basically you are verifying the proof for the case d equal to 5. Now, I'm going to pause the video at this point, and the proof that the answers to these will be in the next video. Okay, so please don't look at the answers first. Please give it a shot, and this is the way I'm hoping that you will check whether you are following along. So if you don't get the solution, please do look, but at least by then you will know that, look, this is what I was missing. So think about what you missed, and of course, if there is a problem, you can always send me an email, or even or come to our office hours. Okay. All right. So let me pause the video over here.